Hello everyone, hopefully you are able to hear me.
Yes, we can.
Okay, thank you. So today we will have some example SQL queries using SQL Let's Studio. And if you look at the lab homepage, in here we have slides for this lab, and also we have a set of query questions, and we also have this SQLite database that you can open and write your queries in it. So if you download this SQLite database, we are going to look at that database now. So remember, in SQLite Studio we could have a bunch of databases, right? In here, let me get rid of this existing lab 3.1. So this was from lab number 2, and now for this lab we have a new database. You can download it from here. And to add a new database, we were going through database and then add a database. In here we could create a new database, but in this case we would like to actually open this lab3.db file. And when you open it, if you look at the tables, in here we have the user table, the partner of table, and the company table. So let's say that I don't know the ER diagram of this database. I'm trying to understand what's stored in it. So starting with the user table, for example, in the user table, if you look at the definition of the user table, we store IDs, and I know that ID is the primary key of this table. We also have name, surname, credit status, date of birth, and city attributes for this user table. Most of these columns are having this not null condition. So whenever I would like to create a new user, I have to give an ID, name, surname, etc. Only for the city information, I can keep it as null. So I can have some records, some users that doesn't contain the city information. If I look at the company table, I store CIDs of the companies, which is the primary key. Additionally, I have the company name and a monthly payment, and I also see the data types for these attributes. So company name is going to be a text, and for monthly payment I'm going to store numbers. And if I look at the partner of table, here I see the user ID and the company ID. I see that it's a table primary key. So the difference is that if you assign an attribute as the single primary key, we were like double clicking on that attribute's definition, and in here we can assign just one attribute as the primary key, but it's disabled now because we have a primary key defined for the table itself. So if I get rid of this primary key for the table, then I'm able to select only one of these attributes as the primary key using this attribute options window. Otherwise, if multiple attributes are going to be the primary key, I was clicking on this button here to add the table primary key, and to add a table primary key we were just selecting a bunch of columns which contribute to the primary key. And similarly for foreign keys, if an attribute is the foreign key by itself, we just go to the definition of that attribute in this foreign key option here. If I click on the configure button, I will see that the user ID in the partner of table is a foreign key that references the user table, and the corresponding attribute in the user table is ID. So the foreign table is user and the foreign column is ID. And to get some benefit from these foreign keys, we were choosing the cascade option for on update and on delete options, so that if something changes in the related table, in this foreign table, for example, if I update some user's ID to a different value, then it's also updated in this table. So we see that user ID references a user, and for the company ID, if I look at the foreign key configuration, the foreign table is the company table and the foreign column is CID. And since we do not have any unique constraints for any of these attributes or any of these foreign key attributes, this is acting like a relationship, a many-to-many relationship, right? In this partner of table, we are associating a user and a company, and for each company there could be multiple partner users, and for each user there could be multiple companies that this user is a partner of. And if I look at the user table's data, I will see that I have a bunch of users. So in the company table as well, I can check the data to see that there are some companies. And if I look at the partner of table, in here I see that some companies are associated with some users. So in this database, we would like to create some SQL queries, and to create an SQL query, we go through tools and we open the SQL editor. So in my version, the text is bigger so that it looks better on your screens. If you would like to do that, the option is through tools, and we go through open configuration dialog, and in here we have this look and feel part, and in here you can change the font type and the font size. So I changed the SQL editor and the data view font, so in my version it appears larger. So a basic SQL query is in this form. So we have a bunch of special keywords like select for projection. Then we give a list of attributes, and we are interested in a bunch of tables, mostly some tables. So select is to say that I would like to project these attributes from a list of tables, and it could be just one table as well. And in SQL, we sometimes write the keywords with all uppercase letters to be able to see it better. And most of the time you might also see that each keyword appears on a different line. So each of these are going to be for us to see it better. Otherwise, for SQL, it's just a string, a line of text. If it is correct in syntax, that's okay for the SQL. And whether you write the keywords with uppercase letters, lowercase letters, it doesn't matter. Actually, you can also like mix and match those cases. So this is the most basic form of an SQL query. To run our query, we are going to use this execute query button, but this is not a correct query, because when I try to run it, it is going to say that, okay, the problem is that there is no such table as tables. So this thing that I write here should be a table name. And also there could be multiple databases in my SQL Studio, right? Here I select the one that I'm working on. So if you are sure that this table name it should be in your database file, then maybe this file that you are working might be not correct one. So in this one I'm working on this lab tree. So the tables that I can use are company, partner of, and user tables. So let me get the user table, and for tables, for example, if I use it with the small letter U, if I try to run it again, actually now it is complaining about that there is no attributes. So in the user table, if I look at the columns, for example, I can project the ID, right? So let me first write it like this. So you will see that this name of the table is actually not case sensitive. But if you start typing it, and if you use Control and the space key on your keyboard, it auto-completes it with the correct case of letters. And if you have the exact case, the exact string for the name of the table, you will see that the names of the tables are shown in blue here. So like you can also write it like user, but then it doesn't change the color. So it might be better to see it. So what's a table name in this query, for example, anything blue is going to be the names of those tables, and if you have the correct uppercase letters, then it will make it blue. So that was what I tried to say. So other than ID in here, what I can project. So in here I can use the control spacebar to autocomplete it, and I will see a list of things that I can write here. So some of them are SQL keywords, some of them are functions, and some of them are the attribute names included in my tables, in different tables actually. So in the company table I had CID, for example, and in the user table I have name. If I double click one of them, I can get that information, and if I run this query, I will see these results. So with queries, we can retrieve our data, see our data in different ways, in different views. And in this case, we are having less attributes. So maybe I'm not interested in all those other columns of the user table. I would like to just see the relation between the ID and the names of the users. This is something I can do. So in this SQL editor, one important thing is that if you select or highlight some part of this text, and if you click on the execute query, then it only executes the selected part. So actually in other sections lab, this was an issue I tried to solve with some student help. So if some part of the query is highlighted, then it only tries to run that section. So if you would like to run the whole query, then you should select nothing, or you should select everything. So that's one thing. So in here, most of the time, instead of just displaying all the data, because we could have millions of users, we put some conditions with the special word where. So with the where condition, I can specify criteria for any of my attributes. For example, I can say that, okay, ID should be equal to 5, for example. This is a valid query. So I can run this query. Then it only shows for the user whose ID is 5. The not equals to sign is this one. So less than, greater than, together. So if I use this, then it will list all the users whose ID is not equal to 5. I have like different combinations, like greater than or equal to, and in here I can use the logical operators and or. So for example, I could have something like this. I can say, okay, ID is larger than or equal to 15, or ID is less than 4, for example. Then when I run this query, I will see the ones with an ID value higher than 15 and also equal to 15, and I will get the ones whose ID is less than 4, for example. And in here I can mix and match these operators together, so I can have something like this as well. So this is making an OR operation, and with two different cases as well. So maybe I can copy this part here and say that in here I have a different range. Maybe it's larger than 9 and less than 7, and with this AND operator we are actually kind of getting the common part which is included in both of these lists. So if it was just the second part, then we get more users, so 9 to 20, for example. And with an AND condition, we can get the common part for these users. So in here, we can also mix and match different conditions for different attributes. I can say, for example, in the user table, we have this credit information. I can say, okay, the ID should be larger than 10, for example. And at the same time, I want this credit amount to be larger than 400, for example. And in this case, let's also project the credit so that we can see and understand that it's larger than 400. In here, next to the select, a special symbol that we can use is the star symbol. It means that project everything. So if I write select star, it means that it is going to project all the attributes of those tables. And let's actually now go through the example query questions. So in here we have them as a text file. We also have these questions in the slides with their answers. So now we would like to go through these questions and try to create or write SQL queries that does the question. So the first one says that find name and credit of the users that have at least 400 credits. So in most cases, in most query questions, it will start by asking us some values to project. So in this case, what I need to project is the name and credit from the user table. So I need the name and the credit. These information are within the user table. So I don't need any other table for now. The user table is enough to get the name and credits of all the users. And among these users, I can say that the credit should be larger than 400. So whether I include the 400 or not, it's like it's not that important. So as long as you write it like this, so in the questions, etc., it might say that at least 400 credits, and you can understand it as strictly larger than or equal to. So that's not that big deal for these kind of questions. And that's the query for this one. So let's continue with the second one. Find name and date of birth of the users born between these two given dates. So this time I want to project the name, and I also want the date of birth. So if I use this autocomplete option, for D we have this date of birth. Again, the user table is enough because these two attributes are in the user table, and according to the description of the query, we don't really need any other information from a different table. We have our conditions specified on the date of birth. So in here, we would like this date of birth to be larger than. So in case of dates, and this can also contain the time as well. So within a date, you can also store the clock in this date type. The thing is, here we would like to refer to dates, and the larger the date is, it's closer to today. So for example, in here, this date with 2000 is larger than this date with 1990. And in SQLite, to say something is a date, we include this information in single quotes. And in here we have a special format. So this special form is year dash month dash and then the day. So we should write the dates in this format so that it recognizes it as a date. So in this case, I want to be like for the year 1990, the month is going to be 01, or you can just type it as 1 as well. That's for the first condition, so it should be larger than this date, and at the same time, because we are searching for the ones in between, at the same time the date of birth is going to be less than the one with 2000. So that's going to be our query. So if I run it, I'll see that these users are within this margin of date of birth. So one other thing we can use here is the keyword between. So instead of saying where date of birth is larger than this and less than this, what we can do is to write between here. And then for the second part, you don't need to really specify the date of birth attribute again. So because this is going to be, so the between keyword is going to work for the date of birth between these two given values. So if I run this, it is going to be the same thing, but one difference is that with using the between keyword, it also gets the ones that are equal to. So alias is here because it's equal to this first date with the 1990 in this example. So that's it for this query as well. Now the third one says that find name, surname and city of the users that live in either Ankara, Istanbul or Izmir. So again, we would like to project the name, surname and the city. These are in the user table, and our condition is for the city to be equal to Ankara, or we want the city to be equal to Istanbul, or we want the city to be equal to Izmir. So for text information, in order for the query to recognize it as a text, we again contain the text in single quote marks. And this is a valid query. I can run and see that these users are in Izmir, Istanbul, or Ankara. Maybe we don't have a... Actually, I thought we had some users that are in Ankara. Let me check the user table. Okay, we actually...
You write it with 3A. That's why I guess it couldn't find.
Okay, thank you. I guess, yes, right. Yes, sorry for that. So now when I run it, I see that the ones are in Ankara. But if we are given a big list of cities, then writing lots of ors and writing the city again and again could be like boring. So instead of this, what we can do is, so after writing city, so this is the attribute, we can say that, okay, this attribute should be in a set of values, and then we write a set of values. A set of values is in between parentheses. We use the comma sign to separate these different items. We give a list of items, and this is an equivalent query. So if I run it, it is going to display the same results. But now it's easier to write. We just give the set of possible results or values for the city. One thing that we can show at some part is that if you make a typo here, for example, for an attribute name, then the error message is going to say that there is no such column. So there is no such column like that. I need a column name that's included in my table. And for example, I might be writing some correct attributes in a different table. So for example, user ID, it also autocompletes this, right? The user ID is a valid column name. But whenever I try to run it, it's again going to say that there is no such column, because in the tables that I include, since I just bring the user table, the user ID is not in the user table. So that's one like message you might see while you are writing queries, so be careful about that. Then in the next query, it says that find name and surname of the users without a city record. So maybe we would like to fill the city information for these users, and we would like to find such users. So we need the name and surname. Now we don't need the city information. It's going to be coming from the user table. And what we want for the city value is going to be for it to be equal to null. So where city is null. If I run this query, I will see that for William, Floyd and Scott, we don't have any city information. I can also come here and project the city, for example, to see that these entries have null city, meaning that we don't have a record for the city column for these entries. And one other thing that we can say is, if you write not null, then it will be the reverse of that. So this time, for all the users that I list here, the city is not null. So again, for example, sometimes we will need to only contain the entries whose values are not null, for example, for some column. And then we have with the fifth question saying that find name, surname and credit of the users whose name start with the letter W, or whose surname include the letter O. So name, surname, and credit are the things that I project, and it's again in the user table. And now my condition is saying that for the name, I want the name to start with the letter W. So for strings, for text, I can say that, for example, name equals Joe. And if I run this query, it will find the one whose name is exactly equal to Joe. Another keyword that we can use here is like. And so far it does the same thing. But using the like keyword, we can use some special symbols. So we have two different special symbols to include in a text if we are using the keyword like. The first one is this percentage sign, means any number of any character could replace this symbol. For example, if in here I come and just write this percentage sign, then when I run this query, it will match for all the names, because for William, for example, each of these letters are used for replacing this percentage sign, and that's a valid thing. And I can also include some real letters in this text. For example, I can write here W, and when I run this, I will see that it is going to, for these two entries, it is going to match the first letter that I include, which is a W. So this exactly matches, and it can be followed by any number of any characters. So most of the time we are maybe searching a part of the text. For example, I can include this percentage sign at the beginning and at the end of my letter. Then it will display if there is a letter W at some position in my text, for example. And this can be also used for some like longer text, for example, O and E. So it retrieves Joe, for example. And I can also include another percentage sign in between, meaning that there should be some O at some position, followed by an E at some position. But in between how many letters, I don't care. But in our database, such an example was only Joe. Let's change the letters. For example, A and E. So this query is finding a letter A followed by a letter E at a different position. And in between these two letters, there could be like many other letters. And going back to this example, we want the name to start with the letter W. So I have W followed by this percentage sign, and then for the surname, so I want both conditions at the same time. I'm going to use this AND logical operator. The surname is going to be like, this time the letter O, it's actually saying that OR, right? I want the ones whose first letter is W for the name, or the ones whose surname includes an O in it. So meaning that O could be at any position, and the operator in between is going to be OR. So for this one, for example, William is here because William's name starts with W, but Brandon is here because Brandon's surname contains the letter O in it. And this is the query for this question. And remember, we talked about another symbol is here, and that's the underscore character. It is going to be replaced by just one character. So with this underscore character, we are actually looking for the length of the letters. For example, I can say here it should start with the W followed by 4 underscores, meaning that after W there should be exactly 4 characters. So if I run this query, then I only get Wayne because William has more letters in it, for example. Or I can use it to say that it should at least have some number of letters. So in here, let me put 4 underscores here followed by the percentage sign, meaning that there should be exactly 4 letters followed by any number of any letters, meaning that this is going to retrieve the names with length 4 or greater. So Joe is not here, for example, because in Joe I have 3 letters. So these can be mixed and matched. For example, I can here say that, okay, for these names I want them to start with M. You can like mix and match these symbols to search for something, but most of the time we are going to like include these to search for some letter or some part of the text within the whole text most of the time, or maybe sometimes you are searching for the length of the text. So the next one saying that find all distinct cities that users live in. So in here I might go and project the city from the user table without any conditions. Then it's going to show the city of each user, but if some users are in the same city, those city names will appear multiple times. And in this case, we are actually looking for the distinct cities, looking for the different cities. So the keyword for that is going to be distinct. So then when we run this query, since a null city is also an option, it will also display the null value here, but I see all the different cities the users are living in. Other than that, we also have aggregate functions to use. So for example, it's asking us to find the highest credit of users. So if I come here and project the credits from the user table, for each user we have a different number of credits. But then I have a function. Now we are interested in the highest value. I have a function called max, for example, and I can use this function for some attribute. So the function max gets the attribute credit in it, and if I run this, it is going to retrieve just one value, maximum of the credits. And one thing important is when we are using aggregate functions, they appear next to our select statements. So that's not to say that I cannot include the name, for example, but one thing is, if I'm projecting the name from the user table, the names of the users could be a list of values, lots of different records, right? But the result of a function is going to be just one value. And in this case, as in SQLite, it shows the first of the name. So if I go to the user table and look at the data, I guess it's even not the first name. So let me just go back to our query. So this was our query, and it just displays some value. Actually, I guess, is it the one with the maximum credits? So let me check. I guess that's the case. So yes, Betty was the one that gets the maximum number of credits, but you should be careful about this because in other SQL variants, this doesn't function like that. So this might give you a syntax error in other SQL variants. So now we are using SQLite, but for example, in MySQL, this will give an error message. So because of such things, in the homeworks and the exams, the teacher wants you to like follow some rules, and one of these rules are going to say that, okay, at the same time, if I'm projecting something, some result of a function, and if I'm also projecting an attribute which could possibly contain multiple records, could be matching with multiple things, then this is not a valid thing to do. So let me get rid of the function. What I'm trying to say is that if I run this, for projecting the name, it's lots of values, right? It's a bunch of records. But if I'm getting the result of a function, it's going to be just one value. And if we try to combine these together in the project statement, that's going to give an error in other SQL variants, and to be able to like adapt into those other SQL variants as well. The teacher wants you to like follow the rules that are common to SQL. So in here, we are just interested in finding the highest credit of users. In a further question, we are going to see how, in a formal way, we can find the user that gets the highest credit, for example. But for now, this is what we do. And we also have other functions. For example, we can write min here. It's going to find the minimum. And we have also the average. AVG is going to find the average of the credit. But then the attribute that we are writing here should be compatible, right? If I write the name here and if I run it, then since the name doesn't contain any number values, the average is going to be not meaningful, right? And in here, for example, if I write the max for name, it's going to look at it in an alphabetical order, for example. Then if I write the minimum of the name, for example, it's going to be again some record, but some operations are not meaningful for some type of data. For example, if I say sum of name, it's going to return 0 because summing the texts are not very logical. So for the 8th one, it says that find the number of users. For that, we have the count function. So in the user table, count the number of users. And again, this is a function. It is going to take a parameter. In here, if you write star, it means that count the users as entries. So there are 20 users in our table. But then we can also look at the specific attributes. For example, look at the ID column and count the users based on this ID values. Since ID is the primary key, it doesn't have any null values, so we get the same amount. But for city, for example, in the city column, we have some empty rows or null values for the city information. Then it's going to only count for the ones that has no empty city values. So for each of these for these 17 users, we have some city information. For the rest of them, we don't have any city information. And we can like write these information together. We can get the count of city, for example, sum of the credit, and maybe the maximum of ID. Since each of these are going to return just one value, I can project these results. So project the results of these aggregate functions together. That's something we can do. But one thing that is not going to be valid is this one. So for example, let's say that we would like to find a user who gets the maximum credit. So in here I can write, okay, I want the name and the credit amount of a user who gets, let's say, more than the average. So in here, maybe you might think that's okay. Let's say for credit, I want the credit to be larger than the average of the credit. In such query, the problem is that for aggregate functions, we cannot use aggregate functions next to the var condition. As a var condition, I'm not able to include an aggregate function because the var statements are going to be applied on individual users. Then if I'm just looking at one entry there, so for one record in the user table, calculating the average does not make sense. So it says that misuse of aggregate function average. So I'm not able to use the aggregate functions next to a var statement or within a var statement, let's say. Instead, what I can do is to include a subquery. So instead of writing here average credit, I'm going to write, okay, I'm including some subquery. A subquery is just like a query, that I'm using inside another query. In here, I'm going to say, okay, I'm projecting the average credit from the user table. So this is a different operation, right? I'm going to go and run this query first, and then this is going to contain just one value. We just executed such queries. It was returning just one value. Then I can use that value next to my var condition. So if I run this query now, then these lists of users are getting more than the average credit, or I can also say that less than the average credit, for example. And now these users are getting less than the average credit. So important thing here is that next to a var condition, I'm not able to directly write an aggregate function. If I need the result of some aggregate function, then I need to use subqueries. And subqueries are any query that I include within my query. To show a subquery, I'm using these parentheses again. And remember that we are able to choose some part of my query. So I highlighted this part, and if I execute it, then I see that this is the average credit value. So now coming here, it says that find name, surname, and status and credit of the user with the minimum credit. So in here, we are going to project name, surname, status, and credits for a user whose credit is equal to the value of the minimum credit from the user table. So this is going to be my query now. If I execute it, then I see my result here. Then this one says that find name, date of birth, and credit of the users who have more credit than the average and was born before 1990. So we are going to select or project the name, date of birth, and credits of the users. And for these users, my first condition, they should get more than the average. So their credit should be larger than the average credits that I calculate from the user table. So that's one condition. So if I execute this query, within the records that I get, some of them are not born before this date, right? So then as another condition, so remember, this is one var statement. I can put another condition saying that, and at the same time, I want the date of birth to be less than this given date. So now if I run it, now I see that for these ones, for example, let me just first select the first part. Some of them, for example, Joe, for Joe the date of birth is 2001. But if I include this last condition as well, then the Joe is gone. So this is for this question. Now it says that find name, surname, and company name of users that are partners of companies. Now I see that name and surname should be projected. Okay, name, surname. These information are within the user table. For the users columns, if I check, name and surname is there. But for this third thing, the company name, if I write here, the company name actually it also shows us that the company name is in the company table. So if I write such query without any conditions, it will fail because there is no company name within the user table. I also need to have the company table, right? Let me include the company table as well. So when I run this query, it will be kind of interesting because in here it appears like William is in Oro Technologies, in Vortex Word, etc. for every existing company, and for every user it is going to match with every other existing company. So whenever you include more than one table, the query is actually making a Cartesian product in between those tables. And to see it better, maybe you can also project everything using the star symbol here. So looking at the IDs, for example, ID 1 is matched with company ID 1 to 10, and for ID 2 it is matched with all companies, etc. Since we had 20 users and 10 companies, it's going to display 200 records here. If I would like to join these two tables, I need to write the join condition as a var statement. So that's one important thing. If we would like to join the tables, then we need to specify how to join them. And if you look at, there is no way to join user and company tables directly because we keep the relationship in a separate table. So to find which user is the partner of which company, I also need the partner of table. If I draw the ER diagram of this database, I will see that in between a user and company there is the partner of relationship, and whenever we need some information in between the different elements of the ER diagram to be able to like connect them together, we also need the things that are on our way. So on our way there is the partner of table. Then if I also include the partner of table and run it, it's going to make the Cartesian product in between each of these elements. So in the partner of table we have some number of elements together, and this is actually this has different pages in it. Actually it says there is this many 5,800 total rows, and I need to like switch the pages to see all of them. So we need to specify the join conditions. So to join, what I need to do, we have seen the foreign keys, right? The foreign key user ID in the partner of table should match with the ID in the user table. And the other condition is going to be for company ID in the partner of table, it should match with the CID of the company table. These conditions are the matching attributes. I know them because of the foreign keys in the relationship, and these should be happening at the same time, so I need to write AND, otherwise it's again doing some part of the Cartesian product. So if I run this now without highlighting a specific part, then it is going to show only the rows where the ID of the user matches with this user ID in the partner of table, and at the same time this company ID in the partner of table is matching with the CID of the company table. So actually we are looking at the relationship, so we are using the relationship, and then instead of projecting everything, what we would like to do is to display the name, surname and the company name for these columns. So instead of projecting everything, we will only display these information. Then we will see that for William is the partner of three different companies. So if I look at the partner of table under the data, I will see that the user number 1 is the partner of these three companies, and if you like double click and check, you will see that these are the values that we are getting as the results of our query. So one other thing, most of the time we might use the same attribute names for the matching attributes. For example, in the user table it's called ID, but in the partner of table we use the name user ID, but sometimes these two attribute names could be the same. Then if we are introducing multiple tables and in some of those tables we have attributes with the same name, we need to be able to distinguish which attribute is coming from which table. In those cases, we need to write the table name before the attribute name. For example, in here I can say that, okay, user ID is coming from the user table, but it's not the case, right? So it's coming from the partner of table. In the partner of table, I have user ID, and the ID is included in the user table. For example, for these other ones, company ID is coming from the partner of table, and from the company table we have CID. It is the exactly same query, but we specified which table each attribute is coming from. In this case, since the matching attributes are named differently, we really don't need to specify them. But in some cases, if these attributes name in different tables are the same, then we need to specify those tables names as well. So let's give a break now, and we will continue at 2:30. If you have any questions, you can ask. Any questions, problems before we start? So one important thing is that if we include more than one table, it is going to make a Cartesian product, a cross product in between the entries of those tables. And if we would like to make the join operation, then we need to specify the join conditions. And those join conditions could be like in here just one attribute. And in some cases, remember, multiple attributes could become a foreign key. In those cases, those multiple attributes should match to the foreign attributes at the same time. So you might need to like include more than one statement for each pair of different tables or related tables, let's say, because in here if I have three tables, so I'm joining the user with partner of and I'm joining partner of with the company table, then I need two join conditions here in between these pairs of tables. And what I would like to say is that sometimes to join two tables I might need multiple attributes matching with multiple other attributes at the same time. So if the foreign attribute or foreign key is consisting of multiple attributes, those attributes should match at the same time. So now let's continue with the other ones. So in this new one, it says find username, company name, and credit and monthly payment of the users that are partner of a company and have at least 500 credits. So this time we can make the join operation and at the same time have some condition for the result set that we have. So first we still need to make the join operation because I would like to show the company name and the username. So name and credit are in the user table, company name and monthly payments are in the company table. So name followed by company name. We also need the credit amounts and the monthly payments. And in here for our projection as well, if I have some attributes with the same name, I can go here and specify which table they are coming from. So this is coming from, for example, the credit is coming from the user table, for example. If I have the attributes with the same name, I have to specify, but if the attribute name is unique among the tables that we currently have, so currently we have these three tables and the name is only contained in this instance of the user table and not in any of the other tables, then I can just refer to them with the attribute name directly. So in here we don't really need to specify which table they are coming from. So on top of these conditions, I have another condition saying that for such users, the credit should be at least 500. So credit is going to be larger than 500. So if I run this query, now I have the results. So for William, for example, because of the credits, William is not here, but Paula is here. The credit condition is satisfied. And I'm showing the company's name and also the monthly payments of that company. So let's continue with the other one, saying that find name and credit of the users that live in the same city as a user named Brandon. So for this one, we don't really need to make or use the partner of and company tables, right? Just the user table is enough for finding other users that live in the same city as a user named Brandon. So I'm going to get rid of this part. So we would like to get the name and credit of these users. So in here I need the credits. And my condition is for the city to be same with a user named Brandon. So going back to my user table, I could first find Brandon, look at the city of Brandon, for example, in this case it's Istanbul. And for the city, I can go and write Istanbul. So this is a correct syntax, right? By the way, for text, it's not case sensitive. So not and here, this is our only var condition, right? I should write here var. So this is a correct syntax. In the syntax, it's correct. But what happens if we cannot find and write the city of the Brandon? This should be like adapting, or let me say it like that. This should be self-contained. I should not need to look up the city information for the Brandon first, for example. But meanwhile, let me also say that, for example, if I make the S uppercase here, then it's going to not match for the values I have. So for text, it's case sensitive when you are trying to match your text. So instead of writing a direct value here, what I would like to do is to retrieve the city information of Brandon. I can have a subquery, right? Here I can select the city from the user table, but this time that city should be where the name of this user is equal to Brandon. So I'm finding the city of Brandon here in my subquery. If I just select and run this subquery, I see that it retrieves Istanbul, but whatever the city of this user is, it's going to find the matching users. Now, if I go to the user table and change the city information of the Brandon, this query will still be correct. One other thing is that now we only have one user whose name is Brandon. But let me go to the user table, go to the data, for example. For Marta, let's say, instead of Marta, let's call this user Brandon as well. And remember, if I change some data, I need to commit it, right? I commit it. So going back to my query, if I run it now, I also have another user called Brandon, but that user's city was not Istanbul, right? Let's check it. The other Brandon was in Ankara, and there are some other users also containing this new Brandon Young whose city is Ankara, but they are not displayed here. The problem is that if we use the equal sign here, for this subquery that we are running, so it executes this subquery. Let me execute this subquery. It returns Istanbul and Ankara. But if I say exactly matches, it is going to match only for the first record. So it only finds it for the exact matches with Istanbul. If I would like to say that, okay, from this set of results, it should be equal, then I need to use the keyword in. So if I run it now it will function correctly. So the thing is, if your subquery is expected to return multiple values, if it has the possibility of returning multiple records, then we should use the keyword in. In here, using equal sign matches for the first record, but in other SQL variants, this might give you a syntax error. It might give you an error saying that, okay, this returns a result set, but you are trying to compare a result set with just one value. Then the correct way is going to be using the keyword in here. So this is one option for this query, but another option is kind of similar to what we are doing in relational algebra. For example, in relational algebra, if we were searching or looking for matches within the same table, what we were doing was to create different instances or rename those tables multiple times. In here, we are going to do that using the keyword as. So using the keyword as, I can give a different name to any of my attributes or tables. So in here, for example, I can write, okay, for this name column, I see name here. Let's name it as Brandon neighbor something, for example. If I execute this query, now I just renamed the column. But I can also rename the tables. For example, in here I can say, okay, user table as U1, for example. Then if I run it, it's the same thing. It doesn't really affect the results, but I just renamed this user table as U1. And in here, for example, I can refer to it as U1 instead of writing user, for example. Then, similar to what we do in relational algebra, I can have two different instances of the same table. I can say, okay, get an instance of the user table, name it U1, get another instance of the same table, name it U2. And this time, instead of saying this, what I'm going to do, let's maybe first look at without any conditions. So I see William lots of times, Paula lots of times. What's happening is that we actually have two different instances of the same table. So if I don't specify where it's coming from, it is doing it for the first instance. But for this name to be the one that's included in the U2 table, I need to specify it exactly. And in general, it's a better idea to specify them with their table names. Now, if I look at, it's making the Cartesian product, right? Whenever I include more than one table, it makes a cross product among those tables. And in this case, I want the cross product. I don't really want to join these two tables, right? Every user is matched with every other user. If I think it like a join operation, then u1.id should be, it can be equal to u2.id, but in this case I don't really want to make the join operation, right? I don't want to see the same user on the same line. What I want to do is, on one side, for example on u2 side, let's say, we would like to find the city of Brandon, or find the Brandon's name here. So u2.name should be equal to Brandon. So if I run this query, now on the right side I always see Brandon, and on both sides I could get the city information, for example u1.city and u2.city as another condition. So on the right side, so on the first city, I'm seeing the city information of Brandon. Or is it not like that? Sorry. On right side, this part, as the second city column, I'm seeing the city information of Brandon. But remember, we renamed one of our users as Brandon also. So one Brandon is in Ankara, one Brandon is in Istanbul, but we see these results. Another condition is going to be, so at the same time, I want the city information of U1 to be equal to U2. So only show the ones if those two cities are matching. Now it is going to do the thing that we want, and it's actually on U2 side we have the Brandon. We don't really need to display anything about Brandon. We already know Brandon. But on the left part, we would like to display the information about this U1 user. And this is going to display it for Brandon's as well. And in here, some other condition that you might want to include is, okay, we might get some IDs, and based on this ID primary key, let's get rid of the ones that have the matching ID, because these are Brandon's. We already know that. If we say that get the results for not matching IDs, then it is going to get rid of the Brandon's. Now we have the people from the Brandon's city. So for the other one, it says that find number of users from each city, display the city name along with the count. So this time we are interested in some information about a set of records, right? While we are looking at the other ones, we displayed the individual entries, but this time we are interested in some information about groups of entities. For these cases, we have the group by keyword. So going back to here, let's first project everything from the user table. These are our user entries. We can group them according to some attributes. So I can say group by city. Let's group these users according to their city information. So in here, one difference of SQLite from other SQL variants is that usually the attributes that you can project has to be a subset of the things that you group by. In here, in SQLite, it doesn't give an error. In MySQL, for example, this SQL query will give an error. It displays it, but while displaying it, it's not really that useful. So for example, okay, I have groups of users. For example, Ankara appears only once. If I don't group the users, you will see that Ankara appears multiple times, Istanbul appears multiple times, etc. But if you group by some attribute, those grouped attributes will only appear once, together with the first instance that it matches. So for example, Brandon, this Brandon is in Ankara, but there are also other users that are in Ankara. And something more is that usually if we are using the group by operation, we want to inspect something about the groups, not the individuals. So this information, so saying Brandon Young, this is about an individual, right? And in here we are mostly interested in the information about the groups. Then instead of projecting everything here, I'm going to project the result of a function. I'm going to project count star. Since I'm grouping the users according to the city information, this count is going to be for each of the groups, and it is going to show us the number of users in each group. In here, I can also project the city information. So I'm projecting the city. So 3 users have null city, 3 users have Ankara as their city, 2 users have Antalya as their city, etc. So now I'm displaying some information about the groups. So Ankara is the thing that I group by. It can be projected, plus aggregate functions. So the rule says that I can only project a subset of the things that I can group by, plus the aggregate functions. So aggregate functions is a different thing for each of these groups. Then in here, if you are to include name in other SQL variants, it will give you an error. It will say that name is not a part of the things, attributes that you group by. But in SQLite, it doesn't give you an error. It just shows it for the first instance within that group. But this information is not that useful. And in the exam and the homeworks, the teacher wants you to follow this rule. The rule is saying that the things that I can project if I group by should be a subset of the things that you group by plus the functions. So now coming back to our queries, so we actually did it, right? Find number of users from each city, display the city name along with the count. So this is what our query is doing here. And then now we would like to find the number of partner users per company. Again, a similar thing, but this time we are looking at an information about different tables, right? So find the number of partner users per company. In the company table, I have just a list of companies. In the user table, I have just a list of users. In the partner of table, I know that which company is associated with which user. But if I need to display the results along with the company name is in the company table. So the difference is that I need two tables, right? I don't really need the user table because in the user table, I have the name, surname. I'm not interested in these values. But in the partner of table, I know that which user is assigned to which company, and the name of the company is in the company table. So right now, I would like to count something, find the number of partner users, right? And that information is actually in the partner of table. So if I just count the partner of table, so this is the number of entries in the partner of table. I would like to actually relate this to the company table, but now it is going to be the Cartesian product between those two tables, right? I need to also specify the join condition. In the partner of table, I have this company ID. It should match with the CID of the company table. Then it is showing me the value for this join operation, after this join operation. Let me project everything here. So in here I have the entries from the partner of table, and they are joined with the company entries, so that I have the company name for each of these tables. And the query was asking that find the number of partner users per company. So per company means that actually for each individual company. And if we look at the company table, the primary key of the company table is CID. So companies are distinguished by their CID, not the company name. So there could actually be some companies with the same name, and for those companies, CID could be different. Those two companies are going to be two different things. So the logical thing here is going to be group the companies according to the CID. So actually, let me go to the company table under data, and let me make one of the companies using the same name with another. So I'm going to commit this as well. Coming back to here. So I would like to, let's start by grouping according to the company name. So if I group according to the company name, then actually we are not really looking at the individuals, right? If I project everything, it will contain information about the individuals. What I would like to do here is to show the company name along with the count of instances after this join operation. So if I show this, I will see that in Aura Technologies there are 6 users. So in each of these companies there are this amount of users. But actually I had 10 different companies. Now I see 9 results because 2 of the companies have the same company name. Instead of the company name, I should actually group them according to their CIDs. Then according to the rule that we just talked about, I'm not able to project company name here, right? In other SQL variants. For this one, it will not give an error. It will function in SQL lit. But since it gives an error in other SQL variants, we would like to follow this rule as well. So for that rule, I then need to project the CID. So if I show it like that, I see 10 different instances. So these 2 companies have the same name. If I group them according to the group company name, they were combined together. Then to be able to also project the company name, I'm going to also group by the company name. So to satisfy that rule, I'm first grouping according to the CID, which is the primary key, which I need to separate different companies. Then within those groups, I already know that each of these groups will be individual companies. For each of those groups, the company name is going to be unique, right? If I look at the CID, CID is going to determine the company name. But to be able to project this information, I'm going to also group according to the company name. Then if I run this query, I get my results, and for these two companies with the same name, I get the different results. Another option that we can do is to use a subquery. So in here we were able to like also group according to the company name. But if I was not able to do that, for example, I might use a subquery. So let's do it for CID here, and let's get rid of the company name. Let's say for this query, I'm not able to get the company name information. It could be in some other table as well, for example. Then what I'm going to do is to say that, okay, I would like to get some result set here, right? This is a query that returns us a set of results. And I'm going to, similar to a table, let's call it some name. Let's call it groups, for example. So I get a result set, I call it groups, and then I can use it similar to a table. So for example, I can select the company name, and then I would like to also display the user count, but since this is a function, it doesn't really have a column name. So I'm going to give a name to that column. Let's call it user count. So I'm going to project the company name and the user count. And this information is going to come from the company table because the company name is in the company table. And as another table, I'm going to use this result set. So remember, this subquery returns a set of results, right? So if I choose it and run it, it returns a set of results. A set of results is similar to a table. So I also gave a name to this table. It's called groups. You can give any name to it. Then, with a where condition, I can join the company table. So in the company table, I have CID information. And in the groups table, in the groups result set, I also have the CID information. I can say that, okay, for the ones that have the equal CIDs, to be able to get the company name, I can use this query. So let me run it. Then in this case, I can also display the company name together with the user count. So grouping them according to the CID and company name at the same time is a choice that we can do. But sometimes the related information might be in some other table. In those cases, we need to use a subquery, get our result set, and then we might join it with some other table. So this is in some cases we might need to write such a query. That's why we see that. So with the other one, it says find CID of the groups with more than 2 partners. So now we would like to get the CID of the groups. Okay, so this is something about the groups. And for those groups, we should have more than 2 partners. So we would like to retrieve the CID from the partner of table. Right, in the partner of table, I know that which user is a partner of which company based on the CID of their CID. And in here, we actually want to group the users by their company ID. So we would like to group the users by the company ID. Sorry, here it's not called CID, it's called company ID, right? In the partner of table, we have the company ID. So let me first just show what we have in this query. If I just show the company ID, that's the information. But if I show everything, I'm matching users with company IDs. And if I group them according to the company ID, then in each group, I have the users that are from some specific company. Then I can also, for example, display the count for those users, those groups. So group by the company ID. So this should be also company ID. So in here I see that for company ID 1, I have 4 users. For company ID 2, I have 2 users, etc. This is similar to what we have done. But now we would like to put some condition for an information about the groups. So for groups, if we would like to put some condition, we have the keyword having. So using this having keyword, I can say that, okay, for count of these groups, it should be larger than 2, for example. When I run this query, this is the information we get. So for company ID, these companies, the count is larger than 2, for example, and the corresponding count is displayed here as well. So next to having, what we would like to write some condition is about the groups, not the individuals. So with var statements, what we were doing is to look at the individuals, right? If this was a var condition, then I'm not able to use the aggregate function. It gives us a syntax error. It says misuse of aggregate function. And with the having keyword, I need a corresponding group by operation as well. And I'm looking for some information about the groups. And next to the having, now writing something about the individuals is not meaningful. So if I say having company ID larger than 2, this again is going to give you an error in most SQL variants. In here it doesn't give an error, but be careful about that. It's actually not something that we would like to do. So next to having, writing something about the individuals is not meaningful. Next to having, we would like to have some information about the group. So but one thing, we can have var conditions and having conditions together. So right now we did not really make the join operation, but let's say that we also would like some information about the users. So let me also get the company table, and with a var condition we can join this, right? The ID of the user should be equal to the user ID in the partner of table, and at the same time the company ID in the company table, it should be equal to the CID of the company. And at the same time, let's say the credit amount of such users should be larger than 400, for example. And then in here, if we would like to also show the company name, so let me project the company name, and then I need to group by company ID and then followed by the company name. And for such groups, I'm looking at the count larger than 2. So if I run this query, now it says that to me, in the company Ocean Arts, there are more than 2 users who has credit larger than 400. So if I get rid of this condition, then it is going to show more groups, because now for these groups we have this many members. But getting this condition back again, this is actually the count of users that get more credit than 400. So I can combine different conditions using having and var. And next to having, we are looking some information about the groups. For example, in here for the groups, I can say, okay, the average of the credit for that group should be larger than 200, for example. then it's going to be a different case. So in here I can use any aggregate function. So now let's continue, increase the credit of the users that live in Ankara or Istanbul by 10. So this time actually we would like to make changes to the entries. We would like to modify our data with a query. So we are starting with update queries. So we would like to increase the credits of the users. So when we are updating something, we just look at one table. We would like to update the user table. At one time we can update just one table. But for the information we can use multiple tables, that's fine. But we are updating one table, so you don't see update user and company together, etc. Next to update there can be only one table name. We would like to set some attribute within the user table. It's going to be the credit attribute. We would like to set it to some value. For example, set it to 6. It's a valid query, but if you run this, it is going to set all the users' credit to 6. In this case, we would like to actually increase the credit amount. So we would like to say that on top of this existing credit amount, let's add 10. If we run this now, let's run actually, it says rows affected 20. So it's updated 20 different rows. If I go to the user table and check the data, I will see that for each of their credits, it's increased by 10. I can also make it relational to some other attribute. For example, I can, for each of these entries, I can get their ID value and add it to the total number of credits. So if I run it, for example, and check the user table again, for ID number 1, credit has this 1 here. For 2, it has 2 here, for example. I can also have the conditions in my update queries. So any var condition that we have seen so far can be included here. And the query asks us to the ones in city, Ankara, or Istanbul, we would like to make this increment. And this is going to be the query to do that. So if I run it, now it says, okay, I forgot the keyword in here. Let me write it here. It says no such function city. It thinks that city is a function because of these parentheses, because I had to include the keyword in here. Now 6 rows are affected by this operation. So set status of the users that were born before 1980 to full. So this is some other update query. We would like to set the status to a given value directly. And this time the condition is for the date of birth attribute, and it's going to be less than 1980. And this was the format that we are using for dates. So now 9 rows are affected, and we set their text to some value, some direct value. Now we would like to increase each user's credit by the monthly payment of the companies that this user is a partner of. So for example, William is a partner of 3 different companies, and for each of the monthly payment of those companies, we would like to increase William's credit amount. So now we would like to again set the credits to be equal to something. So let's say we would like to increase actually the credit amount by X, and for that X we don't know this value. We need to run some query, execute some query to find that value. Then we need to use some subquery. And remember, for each user, this time we are interested in the sum of monthly payments of that user's companies, the partner companies. So let's write this way. So we are going to select something. Let's skip that part for now. So within the partner of table and company tables, so partner of table gives us information about who's the partner of which company, and in the company table I have the monthly payments. Since I need the monthly payment, I also included the company table. And since I include these two tables, I need to join them. In the partner of table, I have the company ID. It should be equal to the CID of the company table. And for such users, what I would like to do is so for the matching company, I actually want to update the user that's outside my query. So for my subquery here, I would like to find the sum of monthly payments, right? Monthly payment attribute. So if I join partner of and company tables through this company ID and CID, this is going to show it for the matching companies. And for a matching company, I can find the sum of monthly payments. So if I just select this part and run this query, the sum of monthly payments for all the companies is this value. So this is not for the individual companies, it is for the partner of relationships. So if I project star here, so this subquery, in this subquery, I include the monthly payments for each of the users that are partner of some company. So Aura Technologies, for example, this instance of the Aura Technologies appears multiple times. Ocean Acoustics appears multiple times, etc. At some position, maybe it appears once. But this is showing the results for each instance in the partner of table. Then saying the sum here is going to give us the sum for this whole column. But instead of that, we are actually interested in the ones whose user ID is equal to the user ID of the individual user that I'm now updating. So in the user table, within the user table, I'm updating each of my entries. And for those entries, I also have some other condition, and that condition is going to be for the user's ID to be equal to the user ID in this partner of table. So instead of saying X here, I'm going to write a subquery. In that subquery, actually, what we are calculating is for this user that I'm updating. So next to the from, there is no user table here. I have the partner of table and the company table. So this user information, this user's ID is actually coming outside my subquery. And for that individual user, I'm actually executing this subquery. So if I include some information about a table that's outside my query in the subquery, that subquery is going to use that information and calculate the subquery per user. On top of that, some users might be not partners of any companies. So for now, if I try to execute this query, it says not null constraint failed for the credit. Credit cannot be null, but since some users are not partners of any companies, this subquery returns null for those users, not for every user. For those users, it returns null, and some value plus null is going to be equal to null. And then it is like I'm trying to set the credit to null for some of those users who are not partners of any companies. So it gives an error. We should somehow say that we are doing this operation for the users that are partners of some companies. So remember, this is just X, right? If it's just X, I can add any var conditions here. I'm going to say that, okay, user's ID should be in this set of user IDs that are partners of some companies. So in this subquery, I'm going to find the users that are partners of at least one company, and that's going to be projecting the user ID from the partner of table. So if I look at the partner of table and project the user IDs only, those users are partners of some companies. And then it's guaranteed that for those users, I will be able to calculate a monthly payment for the companies that this user is a partner of. And then I can increase the credit by that value. So if I run it now, I will see that rows are affected, 16 rows are affected. And if I check the user table, I will see that. So for each user, it's increased by the sum of monthly payments of each companies that this user is a partner of. So the new one says that delete users with credit larger than 1,000, and similar to update queries, in delete queries as well, we delete from just one table, and to say that we write it like delete from. So delete from the user table, and then my condition is for credits to be larger than 1,000. And any condition that we have seen so far, I can write it here, combining with logical operators, etc. So this is one delete query. But if you just say delete from user, then it's going to be deleting everything from the user table, so be careful about that. So there is no simple undo option for any of the deletions that we do here. And for example, the related entries in the partner of table will be deleted as well. So be careful about that. So if I check the user table, if I refresh it, if it was open, now I see that for every user they have less than 1,000 credits. So the last one says that insert a user with this following information. So we are given an information for a new user, and we would like to insert this new user using a query. So to do that, we have the insert into queries, similar to update and delete. We do it to just one table. So we are going to say that insert into. So we never insert into multiple tables at the same time. That's one thing important. If we need to insert values into multiple tables, then we need to have some individual queries that inserts into those individual tables. So with an insertion query, we just insert into one table. We insert the given values, a set of values actually. And if you are going to insert a new user, there are like a couple of different options. One option is to give the values in the order they appear in the table. So in the user table, the order is ID, name, surname. So the same order appears in here as well. So I can go here and say, okay, these are my values. I'm going to give a list of values. So the first one is ID, followed by the name, but remember, name should be within single quotes, and then followed by the surname. The surname again should be in single quotes. Then I have the credit number 100, but this full is going to be a text, should be in single quotes as well. This is going to be a date, right? And we have a special form for writing dates here. So with dash separators within within single quotation marks, year, month, and day. And for the last one, it's the city information for this user. I can give these values in order. So if I go here and insert it, it says one row is affected. If I check my user table at the end, I see this new value. So if I run this again, it will give an error saying that unique constraint failed for user ID. So we know that this is the primary key, ID is the primary key of the user table, so we cannot have duplicate values. So I need to change this 21 into something else to be able to insert this user. So for example, 22, then I'm able to insert it. For a new user, let's say 23, if I want to keep the city as null, I can write null here. For example, I don't know the city of this user. I can write null for any of these values. For this third John Doe, the city is null, for example. But be careful, if something does not let you insert null values. So if I say name is null, then it's going to say, okay, not null constraint failed for the username. I cannot have a new user unless I know the name of that user. So that's the thing. And another form of doing this is next to the table's name, I can specify the attributes in any order that I want. For example, in here, I can say name, surname, ID, for example. Then for the values, I should give them in the order they appear on this list. So let me say, okay, status followed by the credits, for example. So let me also switch the position of these two values, and then the date of birth, for example. And maybe this is not for inserting the city. So for this new user, let's call it with some other ID. So I'm going to insert a new user. And if I check the user table, I see that city is again null, but I'm not writing any null value here. I just said that, okay, these are the attributes. The order of attributes are given next to the table's name. And for each of these attributes, I'm giving the value next to the values. And if I omit some of the attributes, then that means those should have null value. But the important thing is that if something is required, if something cannot have null values, for example, like this, 26 is a valid ID, but if I try to run it, then it says that for date of birth, not null constraint failed. I cannot keep the date of birth null. Why? Because while defining the table for date of birth, we said that it's going to be not null. So that's it for our topic today. Any questions, problems? So if not, that's it for today. See you later. And in the website, we have the slides, the query questions, and the database. You can look at them at your own time. And next week we don't have a lab, and the other week after the exam we are going to after the exam we are going to have more SQL examples, and we will start using Python as well. So see you later.